Okay. So the intermediate value theorem here for standard one is this back on the back wall. If a function is continuous on our interval, remember back from your Desmos activity, all bets were off if the function was discontinuous. I think one of them was discontinuous. Who knows if there's a root or not? Because if it's not continuous, I can't guarantee anything to happen in the first place. If a function is continuous on some interval from a to b, so from left to right, a to b, I have a smooth continuous function, no holes, skips, breaks, whatever. And there is some constant L between f of a and f of b. So I place some value L on the y-axis between the output at a and the output at b, f of a and f of b. So if I have a continuous function where L is between f of a and f of b, the intermediate value theorem guarantees that there exists at least one such constant c within the interval a to b, such that f of c maps onto L. The value of the function at c is equal to L. So by extending that horizontal line out from L, I can see where the function has a constant that maps onto L. There's actually three different places, right? F of x is equal to L for three different constants, and those three different constants are all between a and b. Intermediate means between, in the middle. L is between f of a and f of b, so the constant that takes the function and maps it onto L is also between a and b. There's at least one. In this case, there's actually three. In terms of a practical analogy, going out to Colorado, you start a hike at 8 in the morning from an elevation of 9,000 feet. You end the hike on top at noon at 13,000 feet. Shouldn't there be at least one moment in time between 8 o'clock and noon where you're at an elevation of 11,000 feet? Yes. That's exactly what we're saying here. As long as you're not like jumping across some river or a canyon, it has to be a smooth, continuous walk or hike. So what that graph on the board is also up here on the GeoGebra link I've got posted. Here is some function graph on our interval in green from left to right A to B. So is this function continuous on A to B up on the television screen? Yeah. That's why I've got this box checked off here. Is there some value n between f of a and f of b? So is n between f of a and f of b on the y-axis? No. So let's move it. I can take this slider and position n so that it's between f of a and f of b. Now by IVT, intermediate value theorem, there's at least one value c between the interval a to b that will map the function onto n. Let's figure out what that is. I think there's going to actually be 2 or 3 on this one, but in this case, it's going to give you the 0.62717. 0.62717 is between negative 0.82 and positive 1.08. So the number that the function needs to map onto 0.62717 is between 2 and 7.865. Okay, let's try a couple of these then on the other board behind me now. So I'm going to do 3 different questions here. Here's our goal. Determine whether the intermediate value theorem can be applied to our function on the given interval. So I have a function, I have an interval. If the IVT can be applied, find all C values that take our function and map it onto some constant. Or in this case, it's going to be 0. For 2 and 3, I'm going to try to figure out where the function is equal to 5/2 or where it's equal to 1. If the IVT cannot be applied, explain why. These are called existence theorems. There has to be a criteria met before I can guarantee the existence of a particular value. So I have to know that it's continuous, and I have to know that my value is between f of a and f of b. The a and the b in this case are the endpoints of the interval, -2 and 1. So for our first example, function f of x equals 2x squared minus 3x minus 5. See if the IVT can be applied on the interval -2 to 1 to show that there's some constant c where f of c equals 0 between -2 and 1. So let's check our first thing. Is f of x continuous on -2 to 1? Yes or no?
Yes.
Sure. This is a polynomial. A polynomial is continuous for any interval of real numbers. Okay. Now let's find f of a and f of b. Let's find f of -2 and f of 1. I want to see if 0 is between f of -2 and f of 1. Just like I positioned n to be between f of a and f of b here on this graph. So plug in -2 and 1 to my expression. 2 times -2 squared minus 3 times -2 minus 5. That's 2 times 4, or 8. -3 and -2 makes 6. Bring down to minus 5. 8 and 6 is 14 minus 5 is 9. What's f of 1? I'll plug this same thing in. Change all these x's to 1. 2 times 1 squared minus 3 times 1 minus 5. 2 minus 3 minus 5. -1 minus 5 is -6. Is 1 between 9 and -6? I'm sorry, is 0, pardon me, is 0 between -6 and 9?
Yes.
Yeah. So 0 is between f of -2 and f of 1. F of -2 was +9. F of 1 was -6. Since 0 is between -6 and 9, shouldn't there be some point between x equals -2 and x equals 1 where my function maps onto 0? That's exactly what IVT guarantees. Because 0 is between -6 and 9, there's some point between -2 and 1 where my function maps onto 0. So let's solve for that. Now that IVT applies, find where f of c equals 0. So 2 times c squared minus 3 times c minus 5 equals 0. What do I know about c right now? My c value, I have to know what? Or I do know what?
It's in between -2 and 1.
2. The value where my function is equal to 0 is between -2 and 1, because 0 is between -6 and +9, between f of -2 and f of 1. Okay, well, let's solve by factoring, just like we factored earlier. I need to add it to -3 and multiply to 2 times -5, so that's -10. What pair of factors make -10 when I multiply and add up to -3? So I can split this into 2c squared minus 5c plus 2c minus 5 equals to 0. I can kind of split that middle term. -3c is the same as 2c and -5c put together. Factor out a c and a 1. My factors are 2c minus 5 and c plus 1 equals 0. So my two solutions are 5 halves, or 2.5, and -1. Which one was the one that was guaranteed? My IDT, though, I'm trying to find in the first place. Is it 2.5, or is it -1 that was guaranteed by IDT? It has to be between -2 and 1, like I just mentioned. So it's got to be like you said, Caitlin. It's which one? -1. There's just an extra solution. The one I'm interested in is the value of c that maps onto 0 between x equals -2 and x equals +1. So that would be negative. Your thoughts there? Check to see if it's continuous. Check to make sure that our L value, our N value, in this case 0, is between f of A and f of B. That's the case, figure out the constant c that satisfies where f of c is equal to that value, in this case c. Okay, let's try a rational function. I have a rational function. What else makes this one a little bit different? Rather than a polynomial, now I've got a rational function 2x over x minus 1. What else is different? Okay, the interval is different. Rather than going from -2 to 1, now I'm going from +2 to 6. What else? Yeah, it's not 0 anymore. I'm not trying to find a root anymore. I'm trying to know what constant between 2 and 6 maps my function onto 2.5 or 5 halves. Works very similarly. Just make sure that 2.5 is between these two values when I plug in f of 2 and f of 6. So let's check everything. Is f of x continuous on the interval 2 to 6? In order to guarantee the existence of some number, I have to find the criteria and make sure I'm satisfied for that to be applied in the first place. It's not a polynomial anymore, so it might be discontinuous at some point. Where is this discontinuous at? What value of x makes f of x discontinuous? 1. Is 1 in the interval between 2 and 6? So it's not a problem anymore. Right? I'm only looking at this interval between 2 and 6. Where this function is discontinuous at 1 is not a part of the interval, so it's not a problem. So yes, I'm good to go here. Okay. Now let's figure out what f of 2 and f of 6 are. Because I have to know that 5 halves is between f of 2 and f of 6. I had to position, since this is the intermediate value theorem, I had to position that value, this n value, for example, to be in the right spot, to be between those two outputs. So this is going to be 2 times 2 over 2 minus 1. That's 4 divided by 1, which is 4. Let's find what f of 6 is. That's 2 times 6 divided by 6 minus 1. So that would be 12/5. See, that's 2 2/5, or 2.4. Is 5/2 or 2.5 between those two numbers? Is 5/2 or 2.5 between those two numbers?
Yes.
Then there's at least one number between 2 and 6 where my function is equal to 5/2. There's at least one number between 2 and 6 where the value of the function is equal to 5/2. So 5/2 is between 2 and 6. It's like I start hiking at 8 in the morning, I end at noon. I started from 9,000 feet, I end at 13,000 feet, so shouldn't I have to pass through 11,000 feet at least once somewhere on my hike? Exact same analogy. Okay, so IVT applies. IVT applies for f of x on the interval from 2 to 6. There's at least one constant c where the value of my function at that constant is equal to 5/2. So let's find where f of c, 2c divided by c minus 1, is equal to 5/2, or 2.5. We solve by factoring on number 1. How can I maybe solve for c on this example? What's the process to solve this type of rational equation?
Plug in until you get the right number.
Okay, so guess and check, sure, but we could be here all day. What's a more direct route to the solution? When I have a proportion like this, just do cross products. Find the cross products, multiply the diagonals. The primary and secondary diagonals. So take 2c times 2. That's 4c. 5 times c minus 1. I'm going to write that as 5 times quantity c minus 1. It might help you not make an algebra mistake. I've seen students write that as 5c minus 1 rather than the 5c minus 5 that it should be. Right now, I know my c value is what? What do I have to know about my c value so far?
Between 2.4 and 4.
No. 2.5 was between 2.4 and 4. So the function that the constant that maps my function onto 5/2 is between what table? 2 and 6. Compare your x values and y values similarly. I'm trying to get out 5/2 as a y value or an output. So I know that my input that does that for me is between 2 and 6. So 4c equal to 5c minus 5. So I can subtract 5c. Bring down negative 1c on the left and negative 5 on the right, so c equals 5. Does that kind of fit the criteria we just mentioned? Is that value in the appropriate interval for our function? Yeah. Because 5/2 is between 4 and 2.4, or f of 2 and f of 6, I know that the constant c that my function needs to map onto 5/2 is between 2 and 6. Could you guys try number 3?